Okay, good morning, everybody, and welcome to this California Local Technical Assistance Program sponsored training on fugitive dust mitigation. Before I go much further, I just want to do a sound check and make sure that everybody is hearing me okay. If I can get some thumbs up or...
Sounds good, Tom.
Okay, we're good. All right. Welcome, everybody, as I said. My name is Tom O'Brien, and I am the director of the CALTAP Center. And I want to acknowledge my colleagues Scott Jakovich, Patrick Shiwek from Cal State Long Beach, who are here, have been working behind the scenes, and also Daniel Burke, who is online, who is with the Division of Local Assistance at Caltrans, which is the sponsor of local assistance and the CALTAP program in California. CALTAP, I'm having trouble advancing. Let's see. There we go. The California Local Technical Assistance Program is one of 51 such programs across the country, sponsored at the national level by the Federal Highway Administration, with state support in each of the 50 states, as well as Puerto Rico. Our purpose and our mission is really to connect local agencies across the state. That includes rural agencies and tribal communities with technical assistance in all aspects related to transportation. In California, we're a very large state, and this is accomplished under the direction, as I said, of DLA at Caltrans. The LTAP program is administered on our campus at Cal State Long Beach, but we work very closely with partners in other university-based training centers across the state, including ITS Berkeley and Sacramento State. As I mentioned, we provide local technical assistance program. And if you are interested in any of the offerings that we have, we encourage you to visit our relatively newly launched website at caltap.org, and there you'll find the calendar of trainings, more information on how you can tap into technical support in California through LTAP and our national network of partners, and latest funding opportunities. We also have an equipment loan rental program. Right now, the bulk of our inventory is on retro reflectometers, but we've got drones and traffic radar coming soon. And there's information on that program as well on the website. We do have a regularly issued e-blast. The Division of Local Assistance has a blog as well, where you can get information on all of everything related to local assistance in California. Today's offering is what we expect to be the first in a series of programs that we're packaging as SETA, the Sustainable Engineering Training Academy. And the LTAP program, the local assistance in California, has had a very successful resident engineering academy for a number of years. And this is a program that has been designed here to sort of complement that effort by focusing on, in many ways, California's unique need to address sustainability in construction management and in engineering, probably ahead of a lot of other places in the US. So we're going to be talking about identifying fugitive dust and its construction sources, describing the impact of fugitive dust on health and the environment, presenting some common construction mitigation practices, sharing project-based best practices via case studies, and given where we are located, we wanted to share some homegrown stories with you from Long Beach and a very unique component of local government, which is the port. I think you'll find that interesting. And closing with understanding how mitigation affects the permitting process. We're going to ask you to keep mics and webcams off during the lecture, but given the fact that we have a small group, which we view as a positive, we want to make the question and answer as interactive as possible. So please use the raise hand function to ask questions and unmute as needed. We are going to be doing some interactive polling during the course of the course. And so if you could get set up on your phone, www.menti.com or on your desktop, and put in that code, you'll be able to take part. You don't have to download anything. This is all web-based, but we'll be asking some questions, particularly about how relevant this course is to your work. This is the first time we're offering the course, and we're thrilled that you're part of it. But as I said, we hope to build upon this topic in the development of a certificate-based program that looks at a whole host of topics surrounding sustainable construction management and engineering practices. And Hamid Rahai, who is a professor and director of the Center for Energy and Environment Research and Services here at Cal State Long Beach, is the designer of the program, and he's going to tell you more about how this topic fits into that in a minute. You'll also be hearing from Austin Cho, who's construction manager at the Port of Long Beach, and David Tran, who's a senior civil engineer at the port as well. Ken Taylor, design manager with the Griffith Company, to sort of get a private sector consultant perspective on the topic. And then David Coram, the superintendent of building and safety for the city of Long Beach in Long Beach Development Services Building and Safety Bureau. He'll be wrapping things up for us today. So with that, what I'm going to do is hand it off to Hamid to get us started on the event. But before we do that, since we have a small group, as I said, we would love to hear who you are, what your affiliation is, and why this topic is of interest to you, why you signed up. So if you could just take a few seconds each to tell us that would be really helpful. And I'm going to call on people, if that's okay, based upon who I see on the screen. So Ryan Moffitt, could I ask you to introduce yourself?
Hi there, I'm Ryan Moffitt. I'm a graduate student doing research in the Sears lab here at Cal State Long Beach. I'm working closely with Dr. Rahai. Thank you for having me here.
Thank you. Angela.
Hi, I'm Angelica. I'm a combination building inspector aide for the City of Long Beach Building and Safety and Development Services. And I'm here, I think it's very important to have a little bit of knowledge when it comes to being out on the field and conducting some inspections. Thank you.
Great. That's great, Angelica. Welcome.
Thank you.
Is it Dakour? My apologies for mispronouncing the name.
So that's David Coram from City.
Oh, that's David. I'm sorry. Okay. I'm just seeing the name. How about S. Cross? Okay, well, we're getting the mic set up. Alan Reyes.
I'm Alan Reyes. I'm an associate civil engineer at the City of Chula Vista in San Diego County, in the capital improvement projects design section. And I'm tasked with kind of incorporating sustainability practices in our workflow. And so just wanted to get some experience here.
Excellent. There's an Angela, not Angelica. There's also an Angela. There we go.
Hi. Yeah, sorry about that. It's Angela Spain, Town of Paradise, Capital Projects Manager.
Great. I'm sorry, which town was that?
Town of Paradise.
Paradise.
Oh,
Okay.
yes. Rose de Chico.
Yes. S. Cross. Okay. Chat. How about Bridget McGinnis?
Hi, my name is Bridget McGinnis. I work for the City of West Sacramento. I'm an assistant engineer in the Capital Projects Department. So I manage projects, and my last project, well, our dust mitigation was where it needed to be. We did have a lot of resident concern about it. So I thought learning more to better talk to them about it would be really helpful. So
That's great. Ophelia.
Hello, my name is Ophelia. Thanks for introducing me. I work for Fresno Council of Governments. I'm an associate regional planner. And this is something that's really important topic to us since we're an agricultural area. And dust mitigation is something that we're currently working on implementing. So thank you.
Excellent. That's great. So we've got the South, we've got Central, and we've got the North represented. I'm very happy about that. Gary Hawken.
Hi, I'm Gary Hawken, and I work for the City of Long Beach. I'm the Building Inspection Supervisor.
Great. And then I guess we'll go back once more to S Cross.
Scott Ross.
Scott Ross, thank you. Okay. All right. Well, with that, I think we've heard from all of the people, the participants in the class, and you'll be introduced to the speakers shortly. But at this point, Hamid, please take it away.
Thank you so much, Tom, and welcome everybody to our first training as part of the Sustainable Engineering Training Academy, which is we are part of the California LTAP program. Tom mentioned a little bit about the CERS, Center for Energy and Environmental Research and Services. I just want to give you a brief overview of what CERS is. We are a research and training center housed in the College of Engineering at Cal State Long Beach. It was established in 2003 with a small funding in transportation projects, and it has grown since then quite a bit. Our research are on sustainable energy, transportation, water and environmental technology, building sustainability, environmental health, and we also have patents, and we do technology innovation and advancements. So we do patents and contracts and so on. Our research has grown, as I mentioned, quite a bit over the past 20 years. We have exceeded $13 million recently in terms of the research contracts. We do a lot of applied research. We work with federal, state agencies, industries, and we also do a lot of training. So as part of this training and part of LTAP, as you can see that we have various modules that we are pursuing. One is environmental impact of transportation and mitigations, which is today's training is part of this part of the environmental impact. And as Tom mentioned, we are hoping that to have certificates awarded in this area as we complete all the modules, a series of modules in environmental impact of transportation and mitigations. The next modules or a course that we anticipate would be on structural health monitoring, that we think that is extremely important to be able to embed structural health monitoring into existing and new structures in order to be able to remotely monitor them and continuously, especially during any kind of natural or man-made disasters. So that is coming hopefully in October, November. And then we also have courses on green buildings and certification, water conservation, and overall design for sustainability. All of these are part of again, educational training at CERS, which will be part of the CALTAP program. So with that said, I'm going to transition to today's training, which is, I need to bring it up, one moment. Fugitive dust in construction and road work. And basically, I'm going to talk about what fugitive dust is and, how we categorize fugitive dust and what is the impact of fugitive dust on health, and then transition and to how fugitive dust is calculated. For those of you who do not have much of a background in math, you should not worry about these mathematics. I just want to mention there how these are calculated or embedded in any kind of program for assessing the effect of the fugitive dust or the total fugitive dust emitted from a construction projects. And then I also have shared with you a simple Excel spreadsheet that I developed that you can type in the inputs in terms of acreages and in terms of the wind velocity, in terms of the things that's related to fugitive dust, and you should be able to see how much dust is emitted from your construction projects. There is a new version of that include mitigation. That means that you include the efficiency of different methods of mitigations, and that in there, and it tells you that how much reduction you get in the fugitive dust. So we talk about construction phases and emissions. In generally, when we talk about the construction projects, it could have 1, 2, or 3, or all of these phases that include demolition, site preparation, grading, trenching, building, paving, and architectural coatings. And from these activities, we get a lot of emissions. Now, whether they are from traffic activities, which is coming from the diesel equipments that we have for construction, from off-road equipment, on-road equipment, and paving and so on, or it could be from fugitive dust and architectural coating. So today is focused on fugitive dust. So when we talk about dust, what is dust? Dust is particulate matter that is airborne.
Hamid, can I, sorry to interrupt you for just a second.
Sure.
You want to share your screen and show your presentation?
My screen is not shared?
That's correct.
Okay, so let me go back, and I am so sorry. I thought that I am. Okay. Let me share my screen. I am. Okay. Can you see
There
it
we
now?
go. Yes.
Yeah. Go to presentation mode.
Yeah. Okay. Can you see it now?
Yes. You might want to back up one and then we can, there you go.
Yeah. All right. Sorry about that. I thought that, I had changed the slides from the old one to the new one. Anyway, so I talk about construction phases and emissions, and these are generally the different phases of construction. As I said, that you could have 1 or 2 or all of these phases in construction that include demolition, site preparation, grading, trenching, building, paving, and architectural coating. And we have emissions associated with these construction phases. Now, emissions could come from the diesel equipment that we are running, that include the off-road equipment, on-road equipment, or paving, or it could be from fugitive dust, architectural coating. So today we are focusing on fugitive dust. So what is dust? Dust is particulate matter, airborne due to the construction activities. When we talk about particulate, these are different from the exhaust PM coming from diesel engines. They are generally larger. They are estimated as 15 micron particulate or PM15. But when we do analysis, obviously because of the the way that we formulate PM based on PM10 and PM2.5, we have an emission factors that we use to convert the PM15 to PM10 and or PM2.5. And I explain this a little bit when we get to how we do calculations in construction projects, in calculating the total PM emitted into the atmosphere. So here is also again about the PM to give you an overview of where dust lies in. As I mentioned that when we talk about PM10, it is somewhere between 0.001 micron to all the way to 2.5 to 10 micron. PM 2.5 is the same range, except that the upper limit is 2.5 micron, and PM 0.1 is from 0.001 micron to 0.1 micron. The dust is somewhere between less than 1 micron and 215 micron. So it's somewhere between coarse to fine. That is the range, and it has significant health impact on human being. And it's the same, when we talk about PM 2.5 and PM 10, a lot when we talk about the health impact of those, we're talking about how it impacts the respiratory systems and how deep it gets, and what is the impact of that on the breathing and oxygen exchange and others. It's the same thing it applies here when we talk about particulate matter. So respiratory illness that includes COPD, asthma, cancer is part of the health impact of the dust or fugitive dust. A scarring of the lung that can cause a permanent damage to the lung tissue and thus limit oxygen exchange, that is shortness of breath and fatigue. Swallowing dust and persistent exposure to dust could result in stomach, intestines, and esophagus cancers, So the important things about this part is that the insistence on having all construction workers wear masks. We got used to masks during the pandemic, so it's a good thing. That's definitely mask is a major thing to prevent, or to minimize the impact of the fugitive dust or particulate on human health. So then the question is that how do we calculate this fugitive dust? I mentioned that, that any kind of program that is offered by AQMD or federal or state agencies, and they go based on certain baseline model that they use to be able to calculate the total particles emitted into the atmosphere. And to be able to do this, they look at significant amount of data. They look at the trend of this data. They do a statistical analysis. And based on that, they come up with these formulas to be able to do the estimate. So it's basically looking at the trend of the dust or measurements, field testing from many projects, and based on that, coming up with an estimate of how much dust is emitted into the atmosphere from these operations. So when we talk about grading, if the EF is the emission factor in pound per VMT, and VMT is vehicle miles traveled, then the total PM emitted is that emission factor times VMT. But the question is that how do we calculate VMT for a projects? And then also then what would be the emission factors? So in order to calculate the vehicle miles travel or estimate the vehicle miles travel for a projects, we are looking at the acreage of that, the estimated acreage of the site, and then also then the width of the blade of the facility or grader that we are using to do the grading. So if we use that one, then we can come up with an estimate, as you can see here, that EAS divided by WB. And then the rest of the numbers are basically conversion factors to be able to convert that to the miles traveled, total miles traveled. Then the question is that for grading equipment, the equations are given here that, when we talk about PM15 and PM10 and TSP and PM 2.5, you have these equations. As I said, that we have these mathematical equations, but these are not complicated mathematical equations, but again, we are not emphasizing mathematics here, but rather emphasizing where these come from. And all these correlations that you see here that are from the, again, field experiments and compiling the data and from many different projects and coming up with, that an estimate of those. There are some default values for FPM10 and FPM2 and 5, and they are 0.5 and 0.031. I put these defined values in that spreadsheet, but then you have the ability to change this in case that you see that the data is different. So there is the speed of the vehicle. S is for the speed of the vehicle that is traveling. Generally, the speed of the vehicle is limited to about 7 miles per hour when we talk about the construction, when the vehicle is moving on the construction site. And then the acreage, once we know the area and the width of the blade of the unit that we are using, which is the default value is 12 feet, then we should be able to calculate the amount of the PM emitted into the atmosphere. The average acreage generally for 8 hours per day work is estimated to be about 0.5 for crawler tractors, graders, and rubber-tired dozers, and 1 for scrapers. So these are the average acreage that is, in case that you don't have the dimensions or anything, you can use these default values as an estimate of the area to be able to calculate how much PM is emitted into the atmosphere. When we talk about bulldozing, again, it's very similar that we need to calculate the emission factors and then also the hours of operations. So again, there are equations based on the field data is presented here that we are talking about the M and S as material moisture and slit content in percentage. The emission factors are calculated based on these equations that you can see here. There are C values that are arbitrary constants that with the default values of 5.1, 5.7, and 1, as you can see here. And the default values for MS and F, PM10 and 2 and 5 are 7.9%, 6.9%, 0.75, and 0.105. Again, all these are embedded into the spreadsheet that I provided. So you really don't have to do any kind of calculation. You know that you can just input the input values. I'll go over them in a bit to see that how to do the calculations in order to be able to get the total PM emitted from bulldozing or any other operations. And again, each tab that related to each operation contain these values when we talk about a spreadsheet, but you have the ability to change those in case yours is a kind of different, because we do soil analysis when we do any kind of construction projects. A lot of time we do soil analysis. And when we do soil analysis, then some of the values could be different. So you can put actually the real value to be able to estimate those. Truck loading and dumping and loading cause fugitive dust emission. We will talk about mitigation process when we get to the mitigation time, mitigation practices. But then in general, when the emission factor depends on the wind velocity and material moistures. So you will see that one of the ways that we control fugitive dust is we water the sites. We have a sprinkler or spray water on the top of the piles or areas that we are doing constructions, so to prevent airborning of this fugitive dust. So material moisture is something included into how much fugitive dust is emitted into the atmosphere. Again, there is the emission factor that you need to calculate that, again, depends on the wind velocity and material moisture. The default value are for the, again, default value for the PM10 and PM2.5 is 0.35 and 0.053. But in general, that we need to calculate pounds per ton of the dust is generated because of the wind, and then times the total ton that is removed, and that gives you the amount of the particulate is emitted into the atmosphere. When we talk about demolitions, there are three main operations of demolition that results in increased PM concentration. And these are mechanical and explosive dismemberment, site removal of the debris, and on-site truck traffic on paved and unpaved roads. So these activities are part of the demolitions. You know that when we talk about mechanical and explosive disbursement, is the same equation as truck loading are used, with the emission factor for PM10 and PM2.5 are now about 0.0011 pound per ton of debris and 0.00017 pound per ton of debris for PM2.5. The input to the program for you is, just remember, is in meter per second. I mentioned that in also the spreadsheet, and the M, the default value for M, the moisture is 2%. If there is more than 2%, then you need to change that. So the total emissions pound of PM is calculated by emission factor by the tonnage of the building waste. That is the W, the tonnage of the building waste. If W is unknown, then there is a way to estimate that. You look at the square footage of the building and times 0.046 ton per square foot, and that is basically give you an estimate of the, you know, how much waste you are removing in terms of tonnage of waste that you are removing from this building. And then debris loading, the dust emission from debris loading is calculated from this, again, equation. Again, is include a square footage, and 0.046 is a factor ton per square footage times the emission factors, and K is, again, a multiplier that is used here for PM10. If you are looking at PM2.5, these values are different. And then we are talking about the emission factor is taken as 0.058, which is the average value previously mentioned. You know, there are two values, emission factors that we had before, that you're taking the average of that value for the debris loading here. When we talk about on-site traffic from paved and unpaved roads, obviously fugitive dust is associated with these activities. And for paved road on the left-hand side, you can see the equations. Again, this is a little bit more complicated equations, but it depends on the number of wet days that we have at least 0.01 inch precipitation. So if, you know, N is the number of days, so if you are looking at the total particulate in a month of activity, then the number of days is 30. If you're looking at the annual, it's 365. If you're looking at, you know, seasonal, it's 91 days, you know, that about this. And so W is the average weight of the vehicle, generally is taken as 2.4 tons. It could be different if you are using different kind of vehicles, so that can be changed in the spreadsheet to be able to do the right calculations. So generally, that it's a K factor that you can see is a particle size multiplier. SL is road surface still loading, so you can calculate when we have a paved road, you can calculate how much PM is emitted. For unpaved road, the equation is changed and include mean speed of the vehicle and material moisture content that you can see here. And again, it's saying material slit content, in terms of the percentage. So the VMT, vehicle miles traveled, is included here. And then, again, inputting these values into these equations for unpaved road give you the emission factor. And once you have the emission factor, you can multiply that by VMT. I have a summation here that, that include multiple activities. So depending on, the site that you are, if the site is have the variations in terms of the material and moistures and so on, and for different vehicles, different areas, then obviously you need to calculate them individually and then add them up to get total PM emitted into the atmosphere. So with that said, that is generally an overview of the PM generated. I would like to bring up the spreadsheet, but before I bring up the spreadsheet, I want to know if there is any question. Anybody has any question? No? Okay, so we get going. Let me just bring up the Excel spreadsheet in a moment. Okay. Share this. Um, can you see my screen? The spreadsheet?
Yes.
Yes.
Excellent, excellent. So here I have input-output data that you can see that you can put acreage, all these kind of brownish cell are the input-output data that you can put in. That you talk about grading, you need to put in acreage. You talk about bulldozing, you input the hours of operations. When we talk about truck loading, we look at the tons and miles per hour of the vehicle speed. Then unpaved roads for demolitions, I populate this with the default values for the annual, and the number of wet days would be 30 wet days. You can see that. And then the default value for the material moisture content is 7.5%, and surface material slit content is 6.9%. And for paved road, again, the same value, the default value, and the weight of the vehicle is generally 2.5 tons or 2.2 tons, whatever it is that you are using. I did not talk about architectural coding here because architect coding is related to the VOC, volatile organic carbon emitted from the painting, and that how we prepare the surfaces. That is not, I did not cover those here in this because that is related to another modules. But generally, if you put VOC content, it varies by locations, building surface area that you can put in an estimate of the building surface area, and fracture of surface area that you put paint on, whether it's a 75% for interior, 25% for exterior as a default value, and for painting stripes, car and so on. And again, when you're preparing the parking area, that's an area that you you can put in the default values, the parking lot area, and then default percentage of parking lot that is painted. And it gives you the total PM emitted from the architectural coding. For asphalt paving, again, if you it's about VOC of gassing emission associated with asphalt paving of the parking lot. And you need to put the dimensions and the capacity of the parking lot and give you a total. But those are kind of side things, small projects that you do in preparation of the parking area. That I did not include that in this presentation. But the main thing that is a lot of large projects that we have include grading, bulldozing, truck loading, and demolitions, which is generally related to the amount of the PM emitted into the atmosphere. And that's how you can calculate. So if I put, let's say put the default values of, that about 10 acres, and it give you a value of the 11.75 pounds emitted. If the hours of operations of 8 hours, and per 8 hours, you have over 9 pounds of the PM emitted. Tonnage of loaded and unloaded debris, let's say that we have about 50 tons, and the wind speed is maybe 5 miles per hour, and it gives you about 3 pounds of the PM emitted here. If the vehicle miles traveled is about 7, or it generally, when we talk about this, there are somewhere between 7 to 15. So why don't I put 10 miles here, and it give you 99.97 pounds emitted from the paved roads emitted. So on the right hand side, the yellow portion, the highlighted yellow cells, it gives you the total pound emitted from this activity, which is 124 pounds of PM emitted. Again, a new version that I am modifying this to include the mitigations. And when we talk about mitigations, we are talking about the efficiency of different methods of mitigations. So that new version include those efficiencies that if you put in, you select the type of mitigation that you want, and you put in the efficiency associated with those kind of mitigation, and it gives you that how much reduction in particulate you get, by using those methods. So it's a kind of a way of a kind of trial and error, looking at these, sites, see that, if you change the speed, if the wind speed changes, for example, or the vehicle speed changes, you can see that, that the impact would be significant. So generally, you will see that if the wind speed goes over 25 miles per hour, we do not do the construction activities, because 25 miles per hour really spread the, diffuse the PM into the surroundings significantly. So, but to give you an idea that if you put 10 here, it give you 7.25 pounds of the PM emitted. And then if the vehicle miles per hour goes from, 10 to 20, you will see that significant increase that we have in PM. If you look at right-hand side, we got to 228 pounds of the PM emitted into the atmosphere. So things that you can control is that, the vehicle's speed is something that you have to be aware of it and make sure that, that it does not exceed certain speed, because the slower they are, the less PM is emitted into the atmosphere. And again, it depends on the, acreage, and you don't have much of a control over the acreage of the site, or the hours of operation generally stays around 8 hours. When we talk about VMT, vehicles might travel and so on, if you design the project such that the hours of operation can be reduced for bulldozing, that it can be done with, within the certain number of days, rather than extending these to multiple days or extended operations, then again, you have a control over the amount of the PM emitted into the atmosphere or total PM produced, as I can say that. Okay, so with that said, I want to see that if you guys have any kind of question for me.
Yeah, just real quick, I'm not clear on what slit content is. Is that silt?
It's a sediment material. And generally, it's very similar to clay, except that the size is somewhere between 2 to 60 microns. You know that it is, it's part of the dust or mud or things that you have. It's a mixture.
Okay, so it's I think you're just saying silt, not slit. Is that correct?
Slit is a
Okay.
sediment material. Yes.
Okay, thank you.
I have David.
Yeah, Professor Rahai, I have a question for you. Could you explain the bulldozing versus demolition? Obviously, you see it as two different concepts.
Well, yeah. Generally, bulldozing is compiling the demolition materials. The way that it is categorized in a federal and state agency is that bulldozing is that you are compiling, not demolishing the things. When we talk about demolishing, is that we're talking about that, that we have a building, we want to demolish this site, and then we have different way of cranes and other things that come and hit the buildings, or different way of demolishing the buildings. But bulldozing is for compiling.
Compiling blocks and aggregates and materials on site?
Exactly.
Thank you.
Thank you. Any other questions? No? I guess I'm going to stop sharing here before I go to next. And I guess, Scott, our next agenda is Menti questions.
Yeah. So everybody will take a little break from the lecture. If you could connect up on your phone or your tablet or your other screen to this Menti slide. We just have a couple quick questions to make sure that learning outcomes are coming across, that you're all on the same page with us. Here's the first question. What is fugitive dust? Large particulate matter, dust from emissions, water vapor, glass particles, or none of these? We have two bold respondents. Go to menti.com 716-45949. Then you can join us on this. Okay, let's see. That is absolutely correct. Next question. What are the health impacts of fugitive dust? Would you say COPD or cancer or asthma? Is it none of these or all of these? Okay, it looks like there's a little bit of consensus building. Let's see if that's correct. And that is correct. Excellent. What are the sources of fugitive dust in a construction project? Would that be from grading or bulldozing, maybe truck loading or demolition, or possibly all of these? You'll be pleased to know there are no math-related questions here. Okay.
Excellent.
Got a solid 10 out of 10 on that one. What is EF in calculating fugitive dust from construction activities? Would that be the effective factor, the emission factor, the efficiency factor, the ecological factor, or are all of these incorrect? That is correct. Emission factor is correct.
Excellent. We got 100% from everybody.
All right. Thanks, everybody. Hamid, back to you.
Okay, great. So let's move on to mitigations. Okay.
Hey, Hamid, you it appears you have a question from the court.
Oh, okay. Hello. What is the question?
That was David Karam. He had already answered his question.
Oh, okay. Oh, yes, yes. His hand was up, right?
Yes, we're all down now.
Excellent. So in this segment, we will talk about fugitive dust mitigations. There are several practices that is suggested by AQMD and also federal and other state agencies that we use for containing fugitive dust. As I said, that the new version of this spreadsheet include that the mitigation process, depending on the type of mitigation that we use to control fugitive dust, and that give you that how much dust is emitted into the atmosphere and how we can control. So we're going to go over these in a kind of overall way of using fugitive control for fugitive dust. So when we talk about active demolition and debris removal, the mitigation would be to apply water every 4 hours to the area within 100 feet of the structure being demolished to reduce vehicle track out. Now, when we talk about vehicle track out, you know that you have seen that when we have a construction site, then we have these trucks that's coming out with the dust and piles and everything. And then as they transition to the road, then they have these tracks they put on the roads, adjacent roads. And so we would like to reduce the vehicle track outs, and in order to do that, and also prevent any kind of dust emitted into the atmosphere. So you water the site every 4 hours within 100 feet of the structure. And the PM10 control efficiency for that is 36%. So as I said, that if you select this option to control based on your activity, then the new spreadsheet allows you to put in the efficiency in there for your activity, and then that will reduce the amount of PM emitted into the atmosphere. Track out, use a gravel apron 20 feet long by road width to reduce mud dirt track out from unpaved truck exit routes. So you have this gravel apron that is set on the road, and then depending on the dimension, generally the length is 25 feet, it could be longer, and it covers the width of the road, and then the percentage efficiency of preventing mud, track out mud is 46%. Post-demolition stabilizers, we apply dust suppressants. These are polymer emulsions. I have a list of the approved chemicals at the end of this presentation that I can share with you. That these are used, you apply this to disturbed area upon completion of the demolitions, and it's very effective. So once you once you completed the demolitions, then you can apply these polymers, and the efficiency for that is 84%. Demolition activities, continuously when we do demolition activities, you apply water to disturb soil after demolition is completed or at the end of each day of the cleanup. The efficiency is not much, it's about 10%, but generally I've seen it on the site that they try to continuously do this even during demolition process to be able to control this, and obviously that you don't want to add too much moisture to the site, that because that add weight to the materials that you are removing. So, but then the efficiency for controlling PM is 10%. Again, as I mentioned before, when you are doing demolition activities, if the wind speed is more than 25 miles per hour, you are prohibited to do any kind of demolitions. Construction activities, if you have construction activities, you apply water every 3 hours to disturb area within the construction site. The control is 61%. The efficiency is 61%. Generally, the interval for watering is about 3 hours, a little bit more than 3 hours. So you want to make sure that you have moisture on the site to prevent any kind of airborne particulates. A scraper loading and unloading requires minimum soil moisture of 12% for earth moving by use of a movable sprinkler system or a water truck. There is a huge construction site near our house that every time I pass by, I see that there is actually a truck that is sprinkling water on the site because they do a lot of earth moving removals of the soil and so on. So moisture content can be verified by lab sample or moisture probe. It's based on the AP42 documents. Emission factor equation for material is used here to increase the soil's moisture from 1.4 to 12%. Efficiency for controlling PM is 69%. Construction traffic limit on site vehicle speed, as I mentioned, generally the speed of the vehicles is significant in how much PM is emitted to the atmosphere. Site vehicle speed, limit that to 15 miles per hour or less, and generally it is controlled. The efficiency of that is 57%. That the way they came up with this is they assume linear relationship between PM10 emission and uncontrolled vehicle speed of the 35 miles per hour. So again, the comments give you some idea of that, either how do you apply it or where the source of these numbers are, where we got these numbers. But again, give you an idea of that when you apply different methods of control, then what kind of efficiency you get in terms of the dust control. Conveyors, a lot of time that we use conveyors to transport material. You continuously water spray at the conveyor transit point, 62% efficiency. A storage pile, a lot of time we have enclosures for a storage pile. It's a three-sided enclosure, and the one that is open is further away from constructions, from any kind of exposure or anything that may actually disturb the storage pile. Generally, the other sides have about 50% porosity. It's very efficient in controlling dust into the atmosphere. 75% is the efficiency. Water the storage pile by hand at the rate of 1.4 gallons per hour per yard, or apply cover when wind events are declared. If you do this, then the efficiency go up to 90%. That a lot of time you see that when we have a storage pile, it's covered, especially if they are there for a while until we have truck them out or use them for different purposes. So you need to continuously be aware of that. I have seen that sometimes the storage, some of them are covered, some of them are not covered, because that is a task. It's a difficult task that continuously maintain cover, especially if there is a windy areas. local street, arterial, collector street, local, arterial, and collector street all together. We need sweeping. Basically, if you are doing construction on the side of these streets, and then you have to have a process in place that to sweep the streets adjacent to the construction site continuously. For local streets is 14-day frequency. For local, arterial, and collector streets require together, all together, once per month. And you know that, so there is a frequency of the sweeping. The impact, obviously the efficiency is not as high, but generally when we do sweeping, we remove the percentage of the PM emitted into the atmosphere. So the calculations for this kind of PM10 efficient sweeper is based on 86% efficient sweeping, 8.6-day return time, and California VMT weight sweeping frequency 7 to 30 days. So I give you the comments, give you where these come from. And then if we have mud and dirt track out, you know, as I mentioned, we have a pipe grid track out control device that is installed to reduce mud and dirt from the unpaved truck exit route to come up to the street. And then we also can install a gravel bed track apron. You know, it's generally 25 feet long and 12 feet wide per lane if you are more than one lane. And so to reduce the mud and dirt track out from unpaved track exit roads. The efficiency depends on, you know, if you use pipe grid track out control device, and the control is significant, it's 80% efficiency. If you use a gravel bed apron, then the efficiency drops out to 46% of that. And then if you are looking at the paved interior road, you know, if you want to have any control, it requires paved interior road to be 100 feet long, 12 feet wide per lane. So sometimes, you know, if the construction site is very large, you know, we have these paved roads before the truck come out of the construction sites. And so we to be able to control the amount of the mud and dirt coming to the streets or airborne, you know, because once it comes to the street and dry out, and then the potential for airborne is significant. With any kind of wind speed or wind that come out, or from traffic, from the traffic on the streets, it cause the airborne of the particulates. So we want to prevent that. And if we want to prevent that, if you want to put a paved road, use paved road to control that, it has to be at least 100 feet long and 12 feet wide per lane, and edged by rock bear and row of the strakes, or add 4 feet shoulder for paved roads. The efficiency for that is 42%. Storage pile wind erosion. Again, we talk about enclosure with 50% porosity and efficiency is 75%. And water the storage pile, as I mentioned, by hand or apply cover when it's event. This is the most efficient way of the controlling dust coming from a storage pile. It's 90% efficient, you know, if we do this. And again, you know, it is, if it's a windy, it's difficult, you know, to control, because covering a big storage pile is very difficult and maintaining them difficult. But this is something that has a 90% efficiency, and you definitely you can control the amount of the PM emitted into the atmosphere. Wind blown dust from inactive area. So we apply a chemical soil stabilizer. Again, I said that I have a list of the approved chemicals at the end that I can share with you, that these are the, you know, that apply to the surface. It's applied to inactive construction area. in order to control dust coming out from those, and they are efficient up to 80%. And from disturbed areas, we a lot of time, we could plant trees. I remember that we did an analysis of the how trees affect in controlling the dust and also particulates. The project that we had, it was that mostly related to the PM coming from diesel exhaust. And then each tree was controlling like 10 pounds of the PM, 10 to 20 pounds of PM annually. And then how we plant those trees is important, because that if you plant them in a way that is like a zigzag and filtration methods, then the amount of PM controlled is much higher. So in other words, the areas after the PM, after the trees have much less PM emitted into the air. That those projects are related to, that we did was related to the PM emissions from the diesel engine. But for dust, we can do the same thing, so if you have a young tree, the efficiency is very low. If you have mature trees, 15% increase to 15%. But this method has not been used extensively, other than some agricultural areas that they use the trees or already pre-planted trees on the site for controlling dust. You can, if you have an area that has trees, especially mature trees around the construction site, obviously there is a way of estimating how much reduction in PM you will have, from these trees, depending on the prevailing wind that's coming. Wind blow dust from disturbed area, it's plant vegetation, ground cover is disturbed area, that you cover the vegetation and those areas, as much as you can. So to prevent the airborning of the dust from these areas, and the efficiency is 15%. Grading, again, sources, if you do grading or truck hauling dirts and so on, we generally use covering. I mean, this is the best method for preventing PM to go to the atmosphere. We generally use covering as much as covering, and the covering efficiency is 91%. If you are traveling on, if you have travel on unpaved road, again, we talk about maximum speed. We generally go with 7 to 10 miles per hour speed, but it has to be less than 25 miles per hour. And the efficiency for that is 44%. As I did practice on that spreadsheet, you saw that if we change the speed, it has a significant impact on the amount of PM emitted into the atmosphere. Again, there are different methods for paved and unpaved roads. Watering twice a day for industrial unpaved roads give you a 55% reductions. Paving unpaved roads and unpaved parking areas actually increase the efficiency by 99%. So if you have a large construction site and then you want to have a paved area to prevent dust, that's obviously is additional cost, but it prevents airborne of the particulates. And then also, you can apply chemical dust suppressant to the unpaved parking areas, and that is really effective, and its efficiency is 84%. Okay, with that, we are coming out to large road projects. The rule applies when the project is within 500 feet of an area of public exposure or 1,000 feet of the sensitive receptor. So the public exposure areas are parks, offices, commercial and industrial properties, open space and recreational facilities, etc. Sensitive receptors are homes, schools, apartments, hospital, healthcare facility, retirement, and nursing homes, and so on. That is impacted people significantly. So you know that when we have a large projects, these rules that we talk about, it applies to that. Exception to the rules, you know, when we have life-threatening emergency, a state of emergency, or the activity is authorized by a health officer, these are exception to the rules. Activities conducted by essential utility services to maintain, you know, our utilities, including repair, linear trenching, and other things. These are exception to the rules. Fire fuel reduction, you have seen the firefighters that in order to prevent fire, that you have fire fuels activities along the roads, burning, you know, brushes and so on. So those are exception to the rules. So what are the rules? Dust from construction. First of all, for large projects, each site should have a dust control supervisor who has completed the South Coast AQMD Fugitive Dust Control class with a valid certificate, in addition to all the rules and regulations. You know, that we need to apply restrict vehicle speed to 15 miles per hour for all unpaved roads used for any construction vehicle traffic, and implement one or more of the following control measures as needed in water, all unpaved roads within the project perimeter used for construction vehicle traffic at least once per every 2 hours of active operation, or 3 times per normal 8-hour workday. As I mentioned before, you have seen that we generally we water every 3 hours. That's basically, you know, every 3 hours seems to be work. Or we apply a chemical stabilizer to all unpaved road surface in sufficient quantity and frequency to maintain a stabilized surface. Material pile, as I mentioned, generally it should be covered. It should not be more than 30 feet height, and we apply dust suppressant as necessary to maintain a stabilized surface and prevent visible emissions from extending further than 100 feet as measured from the nearest edge or perimeter of the material pile. So generally that, you know, you want to make sure that if you're not covering and you're using a chemical stabilizer, we do an assessment that within 100 feet, we do some particle measurements. There are some PM measurement devices that actually is a personal PM devices that you hang on your neck and you move around, and then, you know, if after 100 feet, you know, that you're still detecting some kind of particles, then that means that you did not apply enough suppressant. So you need to add more or cover the pile. Install temporary covering or cover, material cover, you know, or put them in an enclosure, as I mentioned, that we have 50% porosity, and that is, you know, that it's important that if you are doing enclosure, the open side of which will face the farthest from potentially impacted area. Again, we talk about impacted areas and that could impact, you know, the populations. You know that if you are using enclosure, the orientation of that enclosure is important, and the open side of that enclosure should be further away from those areas. And here are some of the approved chemical dust suppressants. As I mentioned here, you know that it depends on what type and so on. A lot of time, you know, I'm sure that my colleague Ken will talk about these, you know, the type that they use in industry, but depends on the type of construction you have and the type of activity you have. You could, you know, that apply select one of these chemical dust suppressant to apply. And again, these are more, there are salts, obviously, organic non-petroleum products, road oil, petroleum emulsions that, you know, is being used. and polymer emulsion, electrochemical, and mulch and fiber mixtures. And with that said, there are some also unclassified, and that you can see the list here. But as I mentioned, that the cheapest and the mostly used suppressant has been water, and for controlling airborne of the particulates. So with that said, I want to stop and see if anybody has any question. Yes, any question? No, no question. Scott?
Looks all clear, Hamid.
Okay, so let me stop sharing. And you want to take a break, or do you want to do the Menti? How do you want to do this?
Yeah, I think at this point we're running a bit early. But if everybody would like to take a short break, we could be back at, let's say, 10:25.
Okay, are you guys seeing my first slide with my beautiful face on the front there?
Absolutely.
Perfect.
Yes, very beautiful.
Oh, beautiful. Yeah, that's me, man.
Beautiful.
That's probably 10 years ago, so I'm kind of ghosting you guys a little bit, so sorry about that.
10 is still the same. I don't see any change.
All right, so hey, I'm Ken Taylor. I'm a design manager at Griffith Company. Griffith Company's been around since 1902. Most of our work the majority of our work has been in Southern California. I've been at Griffith now for about 14 months, and I have a background in design for transportation, transit, and city development type work. I was a plan checker with David Karam for a while, who you'll hear from later. And anyway, it's an honor to be here today and to let you know how we deal with fugitive dust mitigation and our best practices. Like I said, I'm a designer and I have some experience out in the field. I have some really good pictures and some good projects to present to you. So let's just get started. So just general discussion agenda for us today. I was going to review some of the AQMD district locations and their requirements and what they require us to do. And Hamid went through a lot of that already. So some of this is going to be a repeat for you. I'll talk about local permitting requirements and the reports associated with that, as well as the state from SWEEPs and WQMPs that we have to deal with. And then also time of year when we can do the work and the duration of the project. We have some very long duration projects and some that, cross our fingers, if we get them, they're going to be a 2-year type earth moving type project out in the high desert. So we're hoping that we get that, because that's going to be a very exciting project. Griffith has come a long way. As you can see, this is a Griffith Company shot from, I think it's in the 20s or 30s, maybe even in the teens, but we were moving sand with horses and buggies. And you can't see it that well, but there's a little boy where I don't know if you can see my cursor, but oh, maybe you can see it if I put it here. Can you see my cursor?
Yes.
Yes.
Yeah, so there's a little boy sitting next to his dad right here on the edge. So I don't know if they had the whole chamber. Here he is right there. Child labor laws and all that stuff. But anyway, we had a materials yard right there along the LA River, and we were hauling sand and stuff like that. So imagine the dust cloud that those horses were kicking up. Anyway, this picture down below is actually a Devil's Gate sediment removal project that we have, which was very large, and I have some really good pictures on this. This was a long time coming. There was an environmental document associated with this that took some time, but lots of dirt. I think we moved 1.3 or 1.5 million cubic yards of dirt out of this out from behind this dam. And we have another one that I'll show you too. I had to step off for a little bit, but I didn't know if Hamid had talked about this, but the air districts in California, there's 35 local districts, and their responsibility is for regional air quality planning, monitoring, and stationary source and facility permitting. And the district administers their air quality improvement grant programs and our CRBs, primary partners in efforts to ensure that all Californians breathe clean air. And this is a very important role for us, so that we can breathe healthy air and that it is monitored. And as a contractor, yes, it's a pain, but we know we have to do it and we know the reasoning behind it. And it's important to us that we protect our workers as well as the residents and the traveling public around our project sites. We want to be safe, make sure everybody goes home to their families every night, safe and sound. Next slide. So I was going to kind of review some of the AQMD handbook requirements, and I took some of this information from Hamid's slides that he had previously provided. We have to apply non-toxic chemical soil stabilizers, and Hamid had a really good list, much more than I am aware of. But those stabilizers do help us save a lot of water, and that's a sustainable element for us. We will replace ground cover where we can. I have a project along Norco Bluffs where we had to remove a lot of Arunda, and we're not putting the Arunda back, but we are actually stabilizing the slopes, and we are putting in pavement and a parkway. So there will be some landscaping put back along our project there. Enclose, cover, water twice daily, or apply non-toxic soil binders to expose stockpiles. We do have that situation. We do stockpile material for haul off days. We also have a materials yard where we crush materials and we store materials that get hauled off and put into other projects. And so those areas do get watered down. We have to water our active sites at least twice daily and as necessary. So depending on how whether it's wind or dry conditions, hot conditions. But Hamid was right. We don't want to overwater even our debris piles and things like that because it increases the weight. But it is important that we monitor those and keep the weight down, because that just increases haul off and dump charges and things of that nature. We will suspend all grading when the winds exceed 25 miles an hour. There's wind monitors, I think, that we have out there that we utilize. And then also, I don't know if it's a NOAA site or whatever, but the guys will use that to help monitor that wind, and they will shut down as necessary. We also will monitor particulate emissions according to the district specified procedures. And if necessary, we'll mitigate with water trucks or shutting down or with the non-toxic chemical soil stabilizers. Here's a couple pictures of how we will secure loads. AQMD requires that secure loads, meaning you cover the loads, you need to provide 2 feet of freeboard below the top bin. So you see the top of this belly dump here, the loads can't get higher than 2 feet from the top of that. And then we also water the loads down too, just to maintain dust. This was on the Devil's Gate project, and we have built a specific scaffold for that, and guys would be watering that down. We also have to sweep the streets, and we use water sweepers, not the dry sweepers. And we'll do that following trucks that are leaving the site. We do it on a regular basis. It's not just one time a day. We'll need to monitor the tracking, which we try to minimize. And but if necessary, we will be sweeping those areas where we're entering and exiting the site. These are a couple really cool pictures too. Let me read the slide here. We set up a truck washing area on a paved access road. That's an AQMD requirement. We did it on site for the Devil's Gate. We did it before they even exited the site. And this is before it got put in operation, this picture on the bottom. But basically the trucks pull into here. And then if you look at the slide on the top, got all these spray nozzles and all that stuff that wash all the tires off. So that helps minimize the tracking out into the local streets. And this is after they get watered down on top. And you can see the dirt might not be quite 2 feet lower, but it should be. But that's the 2 foot of freeboard. That's maybe a foot of freeboard right there, honestly. Like Hamid was saying, that paved construction roads, depending on the truck volume, we had a lot of trucks. There was more than 50 daily trucks out of Devil's Gate. So we were paved out to the paved roads, and we had jiggle strips and things like that that knocked the dust and stuff off of the trucks as well. Applying water 3 times daily. It's probably actually more than that depending on the job site. And then the non-toxic stabilizers for unpaved areas. We like to use that as long as we can steer clear of it for a while too. We use the stabilizers to basically keep dust from coming off that site, and as long as we can stay off it, because if we disturb it, then there's potential for the dust to come off and we have to reapply those stabilizers. But it does help us reduce our water usage as well. Some of the local permitting, this project, these are pictures of some of our rain for rent tanks and cleaning up the effluent or the water that's actually passing through Cogswell Dam. This project is a huge project for LA County where we're doing more sediment removal, and it's we're in our 4th year of the contract. We can only work during the dry season. We can't work during the rainy season. So in the rainy seasons, we have sweepies and stuff like that we have to put up by our yard that's outside the dam, the reservoir, I should say. And then the water quality management plans, this is part of a sweeping requirement too, where we're treating the water before we outlet it past the dam tower. And I have a couple good pictures for that too. Yeah, here it is. So time of year and the duration of the project. This is that Devil's Gate project, which we did during the dry season and all the trucks. This project is the Cogswell Dam, and this is a reservoir for LA County. This has millions of cubic yards of siltation built up and debris from the fires that were in the mountains back there behind Pasadena and Azusa. And so we've had a contract with them, like I said, for I think we're going on our 4th year, where we're removing the silt and debris out of this dam. You can see where the water line is up here. We basically drain the reservoir, and then there's water that's constantly coming in, so we're dealing with that, and that's what those treatment devices were for before we let it go outside the dam. But this has been a very it's a good project for us. It's helping the county with removing the silt from the reservoir, so they increase their capacity. And there was a valve associated with this inlet outlet or outlet tower, and the valve I heard was about 80 feet below this surface here, and they had to replace it. So we dug all that out, and we were able to get in there, and I think they're getting ready to replace that valve. These were 2 very, very big projects for us with LA County. A lot of earth work moving, folks. A lot of earth moving and rock trucks and things of that nature. So keeping the dust down and that type of thing was very important to us and part of the requirements. So I'm a ENVSP too, and I just wanted to touch on that a little bit from a sustainable practice standpoint. Envision is all part of, basically the rating for sustainable infrastructure framework, making sure that we're following steps from the preliminary planning all the way through construction and even monitoring to the end. We'll talk about some more dust control methods, water and reclaimed water, and then polymers and stabilizers that we utilize too. So a little bit of a repeat for what Hamid had. As far as the envision approach, there's a category there, 1.3 for reduce air pollutants emissions. And the intent is to reduce emissions of air pollutants, in particular matter, including dust, ground level ozone, carbon monoxide, sulfur oxides, nitrogen oxides, lead, and volatile organic compounds. So during the envision process, if basically that criteria there for reducing air pollutants and emissions, the metric is reduction of air pollutants compared to the baseline in that area. The credit or the applicability is this credit's applicable to all projects that directly produce any of the criteria pollutants, and projects that do not produce air pollutant emissions because of it's in the design, intentional planning decisions to choose non-polluting alternatives may apply for the conserving level, which is a really good level within the envision process, with the supporting and documentation, of course. So you'd have the reports and maybe even the calculator that Hamid came up with. I mean, that thing would be able to prove pretty well, with regards to, and have the backup for how you're reducing pollutant emissions. So that's a really cool item. Hamid and I apologize because I haven't had a chance to look at that spreadsheet all that closely yet, but I did distribute it to our grading folks to have them take a look at it. So if I get some feedback, I will definitely provide that to you.
I appreciate that. Thank you.
Yeah. Hey, these are pretty cool. I hadn't seen one of these in action before, but I know that we've used them, and I know one of our teammates has used them on this project that we're pursuing. But these spray cannons, that thing's pretty cool, man. That thing's got set up with a tank and sprays out water particulates, and they use them on, this picture is probably hard to see, but this is like a stockpile. This would be a debris stockpile or even one of our material stockpiles to keep the dust down. And this can spread a lot of water in a short period of time, and it also frees up another individual to do whatever they need to do if they're watering down loads or spotting dozers or something like that. We also use these types of irrigation lines and sprinklers to not only deal with dust control, but also soil conditioning. A lot of our sites, the moisture content just isn't there for optimum compaction or moving things around. And so we'll use sprinklers to get out there ahead of time and start moistening up this ground so that we can meet the optimum moisture content, so we can meet compaction requirements and so forth too. Couple desert projects that we're working on, that's been part of our approach on a few of these things. Saves time. I think the other thing that I wanted to mention about dust control measures and water trucks and hoses and sprinklers, if we have the water cannon, we can kind of save this guy so we can go and help do some spot treatments, watering down areas where dozers are actually working. This doesn't show the sprinkler, it got cut off, but this is a large area where a sprinkler could be used to pre-water the area. And then obviously there's the water trucks as well. One of the things that was brought up by one of our foremans, though, too, was, in desert areas and so forth, and we've been experiencing drought, the perception of using water to water down construction sites and things like that. If it's, I don't know, the perception can be that we're kind of wasting water. But if we can use reclaimed water, which is a little bit cheaper too, that helps the whole process, and it's not a waste. It's actually a really good reuse of the water from a sustainability standpoint. Soil stabilizers in lieu of water. we put those on finished slopes. We put them on roads that maybe, or pads that may be undisturbed for a while. And then we do use some soil stabilizers for haul routes too, because we can keep those things intact. There's still water required, but less. And so soil stabilizers help us a lot on haul roads. Dust control strategies for large projects. We've got a project or potential project in the high desert. It's 1,600 acres. It's 30 million cubic yards of dirt that we're moving. It's going to take us 2 years to do it. I mean, it's big. And we've got mass haul diagrams and phasing that we've been working through, and that's required when you're dealing with that amount of dirt. You just can't have everybody going willy-nilly all over the place. You've got to, concentrate that effort in phases so that you can have a succession of work, whether you've got to get to finished grade, start doing your utilities, or whatever else that needs to go in that particular area. If you can get the finished grade, stabilize it, and move the earth moving equipment along, that's very important for the efficiency of the projects. And the types of equipment that we're using is just like Hamid had mentioned. We got scrapers, we got rock trucks. We've also looked at actually conveyors too, where we're moving dirt on conveyor systems instead of trucking. And that has some benefit just from the emission standpoint for trucks. It gets a little tricky. It can limit your volumes, but all things that we've been looking at. Pre-watering, preconditioning of soil. It's amazing how dry the soil is out in the desert. I mean, it's taking thousands of acre feet of water to bring it up to optimum moisture content. And that's a critical item in the desert because you don't always have water in the desert, right? So getting a source for that, bringing it to the site is a very critical item for the construction side of things. Couple more slides here. Soil stabilizers obviously save the water because you don't have to water them. Like Hamid was saying, these are very efficient type of uses. It helps when you're grading areas in phases, like I was saying before, and the soil stabilizers will obviously control the fugitive dust, and we just need to make sure that we don't disturb the area afterward, that we don't drive over it. If it keeps that crust on there, then that's good. We have done a few little studies for this larger project, and we've made statements along the lines of we could conserve up to 10 times the amount of water and up to 10 times the emissions from water trucks, because we don't have to use the water trucks to water the area with the slope stabilizers out there. So there's a lot of sustainability benefits from that as well. Now, finally, that's any questions. If anybody has any questions, we can discuss them now, or I'll stick around to the end as well. Thank you very much.
Thank you so much, Ken. I appreciate it. Very useful. Excellent. Any questions? Anybody has any question? You don't see any.
Ophelia.
Raise hand. Okay.
Hi. So it's not necessarily related to, well, kind of. I know you mentioned that there's some projects in the high desert. I'm actually originally from Victorville. I was wondering what they happen to be, if you could give some information on.
Yeah, I mean, it's public information. We just haven't heard back if we've been successful or not. But it's a big Barstow for BNSF.
Oh, cool. Okay. Thank you.
Mm-hmm.
Thank you so much, Ophelia. Any other question?
Hey, Ken, for that cannon, the water cannon, is that a mobile device or mobile equipment, or how's that work?
Yeah, it looks like it's on looked like they can put it on a trailer. See that up there? That looks like it's on a trailer. This is a skid, right? That probably sits on the trailer. And then you can set it up where it's stationary and it won't walk off, right? But I thought that was pretty cool, man. I'd heard about them, but I hadn't seen one in action yet. So I apologize. I probably got some copyright laws that I violated for this, but anyway, it's really a cool looking thing. And I have to talk to our materials guys to see if they've used this in the past. I know they have water trucks around their material yards.
Is that just for bigger projects that can't handle like a regular water truck? Is that really when he would use these spray cans?
Yeah, exactly.
Okay.
I was on a smaller project just yesterday, and it's like 9,000 linear feet of channel along the Norco Bluffs there, where we put some rock down, but we're moving some dirt behind the rocks. And they just had one water truck, but he was busy. And they had 2 scrapers. They had a dozer there and a couple other pieces of equipment. But
Gotcha.
yeah, I mean, it really does depend on the size of the project. You know, it's got to be economic for that. Thanks, David.
Yeah.
Any other question?
Ken, this is Scott. I'm just wondering, you may have touched on this, and if so, I apologize. Given California's restrictions on water use, are they mandating recycled water use for dust mitigation, or are you able to just throw all that into the air and waste all of my drinking water covering dirt?
We will use it when it's available. I'm not sure about the mandates on that, Scott. I would have to talk to our foreman out there or our superintendent to see what the requirements are. But from what I understand, at least for the small project in Norco that we've been working on, that has been, that's out of a fire hydrant, basically, where they tie up to that. The desert project that I mentioned for Big Barstow, there is a water district out there, but that there's also some well sites that are from previous, they're pivot farms, where they have a pivot apparatus that waters the area. That's where you see all those circles. They call those pivots.
Right.
And there were a couple of those sites, but that's well water. It's potable, I'm sure, but yeah, that was some of the source that we were working. And I apologize, I don't know, Scott, if it's mandated. I can get back to you on that. I'd have to talk to somebody.
Appreciate it. Thanks.
Yep.
Okay. Any other questions? Well, thank you so much, Ken. I appreciate it.
Thank you very much. Thanks for this opportunity. Thank you very much.
I appreciate that very much. Scott, what is our next agenda?
We can we can do 2 things, right? We've got another set of Menti questions, which we can move through. Let's do that because it's they're related to your and Ken's presentation. And it'll just take a few minutes and then we can jump in with Austin and David.
Excellent. Let's do that.
Okay, if you guys will jump back on your phones, just a couple of quick questions. Starting with, what are the main mitigation measures for storage piles? Is it to water them? Is it to cover them? Use storage with a certain porosity? All of these or none of these? That does appear to be the correct question. Excellent. Excellent.
100%.
For large roadway projects, rules apply when the area of public exposure is within how many feet of the project? Is that 100, 200, 400, 500, or who cares? Okay, 100 feet looks like the desired distance. It is 500 feet. Hamid says 500 feet.
Yep.
Similarly, what rules apply when an area of sensitive receptors is within how many feet of the project area? 100, 500, 1,000, 2,000 feet, or even further out? For large roadway projects, rules apply when the area of sensitive receptors is within how many feet of the project? It is 1,000 feet. Did you want to reiterate any of that, Hamid?
Well, yeah, it's a these two distances are very sensitive because it impacts the populations. Especially the sensitive receptors that we talk about, the residential, health clinics, and so on. So we have to be very sensitive to these areas.
And the 1,000 feet, is that an AQMD regulation?
Yeah.
Thanks. Last question, I think. What is the maximum allowable height of material piles? Can they go 10 feet high, 20 feet high, 30 feet high, or all the way up to 100 feet? All right, there's a lot of consensus around 30 feet. That does appear to be correct.
100%. Excellent.
Okay, that's it for me.
Thank you so much, Scott. So now we are transitioning to David and Austin for the Port of Long Beach projects. It's all yours, guys.
All right, sounds good. Thanks. I'm trying to share my screen right now, Scott, and it's not allowing me.
Yeah, sorry, David. We're gonna take care of that right now. You are now able.
Okay, thanks. Give me one moment. Everyone can see my screen?
Yes.
Yeah. Hey, good morning, everybody. I'm really excited to be here with y'all today, share a little bit about the port and Port Long Beach and what it does to mitigate fumigated dust. But I think first, I just want to introduce a little bit about us, me and Austin. I've been working in the industry for more than 15 years, 8 of it with the port and the rest with the Army Corps of Engineers. My education is, I got to obtain a Bachelor of Science in Civil Engineering at UC Berkeley, and then the Master's at UCLA. And most of my experience is with construction management. And as for Austin's been with the port for more than 12 years. And then he actually was an intern with the port, and then he's been here for all his professional career. During his time at the port, Austin has supported and managed numerous construction projects and helped develop the port's most advanced automated shipping terminal pier Middle Harbor. He received his education at Cal Poly Pomona and is a registered engineer and a certified construction manager. And just a little bit of our agenda. I think I'll go over the typical construction contract requirements for fumigated dust control. And then I'll turn over to Austin, and who'll go over some of the type of measures that we've seen for all of our various projects. So with the Port of Long Beach is the port of choice, and it's the premier U.S. gateway for the Trans-Pacific trade and a trailblazer in the innovative goods movement, safety, environmental stewardship, and sustainability. The port handles trade value at $200 billion annually and supports 2.6 million trade-related jobs across the nation, including more than 600,000 in Southern California. We pride ourselves as a top-notch customer service and operational excellence. And in 2022, industry leaders named us the best West Coast seaport in North America for the 4th year in a row. Founded in 1911, the port today encompasses about 3,200 acres with 32 miles of waterfront, 10 piers, 80 berths, and 72 gantry cranes. In 2022, the port handled more than 9 million container units, and it's the second busiest year in our history. So just going over this, this is contract requirements. So this cutout right here, excerpt, is really our typical construction contract requirement related to dust control, and it refers to the Southern Coast Air Quality Management Rule 403. And this is usually found in our general conditions, as you can see here. And what is Rule 403, right? Just like the purpose of it, and this is straight from the manual itself. And Rule 3 is just there to ensure that dust mitigation and control are implemented, and for the contractor to be proactive about it. Typically, the dust mitigation measures and work plan would be included, and that would be a construction submittal that would be submitted to us as part of the environmental protection plan. So then we can review it and have one of our environmental specialists look at it as well. So there's really two categories. One is defined as just a typical operation, and then another that's defined as a large operation. And if it's not a large operation, the general requirements are that one, dust emissions should not exceed 20% of opacity and maintain good visibility. And then two, also the track out be less than 20 feet from the operational activity. And that's really just a summary of the what's defined as not large operation. But if it is a large operation, right, what happens there? So this is a form, and I pulled out the specific project with Griffith since Ken is in the audience. And this is so if it's a large operation, it's typically defined as more than 50. The disturb area is exceeding 50 or more acres, or that any earth moving operation with a daily earth moving volume of 5,000 cubic yards or 15,000 cubic yards within a year time frame. So if that's the case, then the contractor is obligated to send in this form, the 403N form, and notify the Southern California AQMD. And this is a form that was submitted by Griffith from one of our previous jobs that was defined as a large operation. And typically this form is good for 1 year and would need to be renewed annually if it's still defined as a large operation. And this has to be submitted within 30 days prior to the expiration date. And typically this is part of the package as well. So one of it is the form, and then there's a little bit some backup that would need to be done too. So this is another kind of demonstrate what is the project area. And this needs to be included with the form as well, the form 403N. And in it too, they have to include the responsible person to maintain and implement dust control and any mitigation measures, and as well as maintain the daily record of dust control activities and any other associated activities with it. And typically the responsible person is the project manager or the superintendent or the project engineer. That's typically what I have seen on my jobs. And then also install and maintain project signage with the project contact information on it. So this is an example of the signage that was kind of posted at the front or the entrance to the project site. So just in case if there is any, if there's dust and the visibility is poor, this is someone that is driving through the site and they see it, they can call the person, and then this key personnel would be able to kind of implement some of the measures that are needed. And typically these people of responsibility will have to complete the AQMD Fugitive Dust Control class and kind of submit that certificate with it. And with that, I want to turn it over to Austin, and then he'll go over some of the kind of mitigation measures that we do.
Awesome. Thanks so much, David. Hey, thank you everybody for joining us today. Like David mentioned, my name is Austin Cho, civil engineer and construction manager here at the Port of Long Beach. So yeah, my next 10, 15 minutes or so, I really wanted to just highlight, I guess they're case studies in a way. They're two major programs and projects we've had here at the Port of Long Beach that completed pretty recently that, we thought were really applicable to this subject of fugitive dust and how we control it. Like David mentioned, we're on the owner side, right? So it's a collaborative effort. A lot of the responsibility does fall on the contractor to have to, meet the contract in terms of mitigating fugitive dust, but it's a collaborative effort, and the owner has their responsibilities and things that they can do as part of the projects to help that effort. So I wanted, apologize ahead of time. David and I were kind of joking before this, where I think it's kind of a lot of the same presentation slides that you guys saw already, probably with Ken and with Hamid, but I think our focus really wants to be more of like how this applies to the port. For those of you on, a lot of you are Long Beach residents or locals. So, I think the port is pretty influential to Long Beach, and I think you'd be interested to know about some of the fugitive dust efforts, dealing right here next to the ocean. So first one here is Middle Harbor Terminal Redevelopment Project. This is a project and a program that's super close to my heart. Right out of Cal Poly Pomona, I started as an intern at the Port of Long Beach, and they stuck me out in a trailer in the middle of that barren terminal right there, and told me to get to work. So I did that for the next 10 years of my career. So a huge part of my growth and personally as part of me being an engineer here. So the overall scope of the project, right, or why we did this entire redevelopment of this terminal was to pretty much bring in larger vessels from Asia and wherever we were getting these vessels from. We were getting massive vessels that needed deeper channels and more cargo room and volume to be able to offload these, and then overall to also reduce emissions. That's going to be a kind of reoccurring theme through my presentation too, is we are the green port, and we're one that we really want to focus on trying to keep the environment clear and sustainable. And it was a 10-year duration project. It's a program really, so it was split up into multiple different contracts, construction contracts. Overall, the entire program was about $1.5 billion. Before we move on to the next bullet, just to kind of show you some pictures, right? In the top right corner, 2011 that was really the what the terminal used to look like. It was spread up into 2 different berths, and really the goal was to make one giant mega berth that would, you could see that in the finished concept just to the right of that, and that's what we were trying to achieve. And 2015 construction down bottom left is kind of what you see that process entailed is to fill that area and to deepen the channels and drive piles and build wharf. And so now you can see present day, we have something that literally looks like a Tetris maze of container terminals and cranes. So a marvelous feat, one of those kind of milestone projects that you could tell your grandkids about. So awesome project. Just the sheer size of the program and the project, 300 acres. So that's like 12 football fields. Football season just started, so you guys can kind of put that into perspective here. 5 million cubic yards of fill and dirt. So this is really where it applies to this presentation, right? It is the sheer amount of soil and dirt we had on this project. A lot of it was fill material, so it was material that was getting put into the water directly to build land. But I'll talk about it more in the presentation. But a lot of it was dirt that was out of the water, stockpiles, millions of cubic yards of stockpiles outside of the water too that we had to control. Fun fact, that's probably 5 million cubic yards is about filling up the Rose Bowl 2 times. All right, next slide, please. So yeah, I mean, we'll just go over the next couple of slides about Middle Harbor dust control. You can see the top couple of pictures. Again, the sheer amount of dirt and soil that we're moving. Top right picture there is you could see a lot of truck movement in order to build this land. It was both with dredge vessels, waterborne vessels, as well as truck vessels too. So all right, next slide, please. Okay, so obviously kind of 101 again, back to what is the best way or best BMP really to control dust and airborne dust is really just to create that physical barrier, right? Prevention is always better than mitigation. So as per our contract requirements, we require that all material stockpiles be covered. Typically, like Ken would go over, we would be using visqueen 10 mil plastic sheeting. We would see that. I bring up on the owner's side, right? Change orders and stuff is a huge thing as part of the owner's requirements and whatnot. So at Middle Harbor, like I mentioned, we had a bunch of different contracts working together. We had overlapping contractors, Griffith being one of them. in their own areas and overlapping with each other. So stockpile management was a huge undertaking. It was difficult to do, especially when you had situations where I think there was an example where we had conflicting project boundaries, right? So that ended up resulting in a change order of material that we required one of our contractors to have to excavate. So everything in terms of stockpile management now with that extra material becomes change order, right? It becomes extra cost. So I think it's key to note that on the owner side, what we really wanted to do was, once the stockpiles were developed, we pushed the contractor to do whatever they could to expedite, getting these stockpiles offsite, whether it was surplus soil to, haul it to a waste facility, or whether it was something that we as the port could maintain in one of our offsite facilities, or if it was for reuse purposes within backfill. But the main kicker is, as long as these stockpiles are on site and all the effort and cost and time it takes for contractors to maintain these stockpiles, it's a huge undertaking. Like Ken mentioned, right? It's stuff that the contractor really doesn't want to do, honestly, right? They're in the business of constructing and maintaining stockpiles is a tedious undertaking to do, especially with the sheer amount of dirt we had. So I use the analogy of, like, I hate wrapping Christmas presents. So imagine you have rolls of plastic sheeting and biscuit and having to cover these, obscure looking stockpiles. It's not easy to do. So you can see at the bottom right picture is just like a typical situation where you have like a rain event or anything high winds, and that's what your stockpile ends up looking like. And then you have to devote so much time and effort to getting that back. So the next slide, please. All right, so the main theme we're probably going to hear throughout the entire presentation and class today is, right, keeping the site saturated. So obviously water trucks is kind of dust control 101, especially with the sheer amount of volume we had and area we had to deal with on our project. Water trucks was the main BMP we used to control dust. It's very versatile. You can run multiple trucks at a time. You can cover a lot of ground. The biggest thing for the owner side, though, right, was that we are the green port. We're the port that's supposed to be building this terminal for innovative purposes. We're trying to, implement shore power, electrify the terminals. We're trying to get away from diesel and emissions and all that. So when you have 6 or 7, 8 water trucks running on the site, it's not a really good look for the owner side. So I know early on in the project, I think in 2012, I think one of our contractors did attempt the whole sprinkler system method. Obviously, that mitigates the amount of trucks needed, but you also have very limited coverage, and you have a site where, again, multiple contractors running over each other. You had a general contractor or a subcontractor rolling over the sprinklers of a different contractor, right? Destroying all that. It wasn't a good look, and it didn't work out too well. But for stagnant sites or smaller sites, sprinkler systems were a good method to use. All right, next slide, please. All right, so Ken mentioned this already too. Soil stabilizers, excuse me. So I did want to mention one aspect. Go into the bottom right picture first. Surcharge material. So for those that don't know, what surcharge is really. It's when it comes to waterborne construction, right? Surcharge is a consolidation method. So for us, if you can imagine, we're trying to literally build land in the water, right? So you pretty much have to worry about consolidation. If you were to just stick dirt inside water and wait for it to fully consolidate, you're talking dozens, in the 30 some plus years of time. So you really have to implement a consolidation method, and that method included surcharging the material and also wicking the material. So when you say wicking and wick drains, what that is you can, like, wick as in a candle wick, right? So you would probably see 1 million of these wicks throughout the site of where you put in water that would extract the water from the fill material, while you also overload the fill material with additional cubic yards, so you could squeeze everything out and you're pulling the water out. So that effort, you end up shrinking something that should be taking dozens of years into a couple of months. So it was a huge design element of the project, but ultimately you have a situation where you have a literal mountain out there of material. With that kind of coverage, right, it's not something that's a 30-foot thing that we can just use plastic sheeting on and cover, right? This is no longer something where you can just cover the stockpile. This is a mountain. So You obviously have to implement, water trucking on the top, but the big thing, like Ken mentioned too, was how do you control these slopes? These are slopes that you can't reach via water truck. You can't have a laborer on the bottom shooting water, to reach the whole slope 2-3 times a day. So what we implemented was, these chemical polymers that pretty much almost kind of crystallize or crust the soil, right? You change the chemical composition of it. We used a company called Soilworks. Gorilla Snot, I think, was the product name. I think it's the same thing that I use for my hair to gel my hair. But the crazy thing about this was, our site was always changing, even the surcharge, right? We would have to have traffic going in there. So I think what we learned too was it is very, like, this soil stabilizer is pretty sensitive, right? It's not something that you can apply once and then forget about it. You have even foot traffic running over there, let alone one truck traffic. Your entire system of the stabilizer is kind of gone, because you can see in that top picture in the center there that it only just affects that top layer. Everything under there is still very granular, and you expose that, it's the same thing as exposing a stockpile, taking off the sheeting of it now. So it was a lot of work to maintain. It was a lot of costs and a lot of time that we had for the contractor to put towards that. You always had to reapply as well, so I think you're only talking a couple of months at a time. So but it was a needed effort. So yeah, next slide, please. All right, and then just the typical site traffic management, right? So obviously implementing things in the entrance and exits of the site, of the construction site. One thing that's, people overlook all the time is construction speed too, right? We want to try to obviously keep the safety level high in terms of making sure that, we're not speeding on through the site. But the biggest thing that also controls is the amount of dust that's in there too. All right, next slide, please. All right, so that was for Middle Harbor. This next one is the Gerald Desmond Bridge demolition. For those of you who are from Long Beach too, very close to your heart, I think, and what you see every day is this new Long Beach International Gateway Bridge. I think is the formal name of the new bridge that got put in here for the port and Long Beach. In doing and getting that whole bridge built, the old bridge, Gerald Desmond Bridge, had to come down. So this project, as you can imagine, included a crazy amount of concrete crushing and taking down these piers and these columns. So it's not just soil and dirt that we have to worry about in terms of fugitive dust. It's concrete as well. So just a quick look at this project. Is a 3-year duration, is about $28 million. And really where the issues came up, and we'll see some pictures that are kind of worth a million words here, is when we were doing the work to take down some of these piers and these columns, we had neighboring tenants that were complaining about the amount of dust and concrete that they were having to pretty much breathe in. A lot of these longshoremen that are very have very critical jobs, they're now having to work within fugitive dust areas, and they weren't happy about it. So it was the issue that came up very early on the project. And if we can move on to the next slide, David, we can see kind of what we had to do. We implemented something that was very specific, I think, to something like a job like this. It wasn't just water trucks, it wasn't just people with hoses. It was a person with a hose on top of a giant crane. So that was brought in to really hose down the construction as we were breaking down these piers and these columns. All that rebar, all that concrete that was being crushed up at the top there and cut had to be sprayed while that work was being performed. So that was a huge undertaking and a very specific, really haven't seen that before in most people's careers. Next slide, please. So I know we were actually bringing up the topic, and David and Ken were talking about these misters, or these cannons, this hydro cannon. So you can kind of see in this picture that they were implemented here on this demo project. David, on the very, very bottom left corner, you can see where that hydro cannon is spraying mist out there while the work is being performed. And I think you can also see one in the middle picture on the right, where you see a hydro cannon just facing up towards the bridge as it's coming down. But yeah, so I think the big picture here was for fugitive dust and concrete, we employed so many different methods. It was ground coverage method. It was even people with hoses on the ground level, but it was also kind of more innovative techniques such as using cranes and directly watering at the source of the construction, and also mister units. I don't know the exact number. I'm hearing numbers in the range of a couple million gallons of water that was used for this 2-year project to take this bridge down. All right, so I think that might be it, David. I don't know if there's another slide. Yeah, I think that's it, folks. So thanks so much for your time, and welcome any questions.
Thank you so much, Austin and David. Great presentation, great examples of, also the type of innovation that we have to do to control the dust. Any questions? One question I have, Austin, is that did you use ocean water? What
Say
kind
it
of
one more
water?
time?
Did you use the ocean water to be able to control this? I mean,
No, I don't think it was. I mean, I think it was regular. That would be pretty cool. Yeah, I don't think it was.
Okay. Any other questions?
I have a quick question for Austin. In building out the terminal, and I forget what you called it. It was surge or surface, or what was the new material that you had put to
surcharge?
Surcharge, yes. In building up that surcharge, is that dredged in from around the area from the water as part of making the channels deeper for the bigger boats, the bigger container ships, or do you ship that or truck that in?
It is a great question, Scott. It was actually a combination of both a lot of times, and it just depended on the area. We would have a lot of dredged material because it kind of worked out, right? Because we had to make these the channel deeper for these larger vessels. So we would have to, whether it was clamshell, literally just, like scooping up material, or it was hydraulic dredging, which was piped in from the ocean. Some of that was brought in as surcharge and fill material. But then we also had a lot of good quantity that came in from neighboring areas and all throughout Southern California too. So of dry material that was trucked in. So I don't know what ratios, maybe David, if you remember approximately how much was dredge versus fill, but it was a combination of both.
Yeah, I want to say that it was really a split. And to add to Austin's point, we did have, like, when the program first started, we did have an EIR where we had to take in some of the material from surrounding areas as part of one of the kind of measures that we would have to accommodate to develop this with the EPA. And I think there's certain requirements. Some of these fields have really kind of tight requirements in terms of what area gets filled where, as well as anything that goes below water. There's a different requirement than anything that goes above the water table.
Interesting, thanks. And can I ask, when it comes to applying a chemical stabilizer or a chemical mitigation approach like the soil works, is that still a special case approach, or do you think that this is becoming more and more common?
Yeah, I think it was very specific to just that process. I think, in regular soil stockpiles, I think you do what you can to just control that via physical barrier. I think in this situation, it was an innovative approach. I don't know if we'll see mountains of dirt like that in the future. We'll really need to implement that again here at the port. I'm sure on Ken's jobs over in the IE and closer to that, I think you're probably handling a lot more dirt where that's a little more common. But here at the port, I think, especially us being as close to the ocean as we were, I think we wanted to try to limit a lot of that, even though, I think they advertise themselves as being, non-hazardous materials or anything like that. I think we still wanted to just limit the amount of foreign, fluid or polymer in that area.
Thanks.
Austin, I have a question to follow up on that, on the chemical polymer fluid. Was that also approved by the Regional Water Quality Control Board or anything? Were they worried about that material going into the water or anything?
Yeah, that's a great question, James. I'm not too sure. I think that was probably something that was handled at the design level, but it was part of our original design. So I am assuming there wasn't a change or anything to the contract. So I do believe that, I'm sure the port had to go through its all of its regulatory requirements to make sure to use that within that area. But yeah, David, if you recall, I'm not sure though myself.
Yeah, we passed it. I think it was once something that was proposed by the contractor, and we got the product data, and there was some kind of verbiage that said, "Hey, this has been used and is environmentally considered environmentally friendly." And then we also took the step of kind of passing this product along for our environmental folks for review as well, and it was subsequently approved.
Okay, great, thank you.
Any other questions for David and Austin? Okay, hearing none, then we are going to David Horam and the city of Long Beach. David, is all yours.
Well, can you hear me?
Yes.
All righty. Let me see if I can share my screen first. Can everybody see my screen?
Yes.
Okay. Yes, my name is David Khurram. I'm the Superintendent of Building and Safety for City of Long Beach. I'm a licensed civil engineer and have been in the industry of construction and serving public government for the last 40 years. It's a privilege to be a part of this group, and I want to thank CALTAP membership, CALTAP managers, and people involved, such as Tom, Dr. Rahai, and Scott, for this opportunity. I see my role mostly as a regulator, and this morning I've been listening to the presentations. We obviously had a presentation by educators. We had a presentation by a design person, Ken Taylor, that I used to work, had the privilege of working with him for 10 years in past. And we also heard from construction managers and project managers of the port. So my presentation would be maybe the fourth leg to this effort. And I'll speak mostly from the standpoint of a regulator and where we get our regulations from and how we enforce it throughout the city of Long Beach. I have been a building official for 20 years for different jurisdictions, but I focus my presentation based on what I have learned in industry and what we do currently in Long Beach. I have a presentation scope that I will go through. We'll warm up the group a little bit about the different bureaus and different divisions and departments in a city, which is typical to cities, that regulate and has something to do with the fugitive dust. Basically, building department, fire department, health department, public works, and even business license sometimes get involved when the contractors or grading people work in the cities. We heard in this presentation that when the grading happens or the dust work happens where we have receptors, where you have public and people who are very close and intimate with the dirt work, cities become more concerned because we are talking about dense areas where the grading and construction happens. We have diversity of the sizes of grading projects from large to small, but small sometimes is important to us as well because it's a neighbor lives next door. When somebody demo their house and do grading. So sometimes we're talking about a proximity of 5 to 10 feet when it comes to port cities like Long Beach. To fugitive dust and its ramifications. Basically, the department that I run, we have a permit center, plan review, and inspection. All these groups and all this staff are trained to deal or ask right questions before we issue permits. And I'll get to it a little bit today. Then I get more specific about the projects that we deal with, which deals with fugitive dust, mostly demolition permits. I will provide you a couple examples of the projects right downtown Long Beach that we recently worked on or we're currently working on, and the issue about grading bond, and how we potentially hold the contractors responsible for what they do around the city and keep their bonds, release their bonds. I'll get a little bit into that side of it. Then finally, I open up to any answer and question session. A little bit background about City of Long Beach. We are the 7th largest in California with a population of near 500,000 people. The Department of Development Services that basically regulates work within the private property in Long Beach is Development Services with a staff of near 200 people. My bureau, Building and Safety Bureau, with a 70 people staff, directly report to the Director of Development Services. We do permit all construction projects on private property, of course, and public works deal mostly with public right-of-way. So if there's a grading or fugitive dust matter, if it's on a private property, my department, my bureau, my staff will deal with it. And if it's in a public right-of-way, public works obviously permits that and regulates that. In addition to the building project and private property projects, in Long Beach, Queen Mary Historic Ship, all the is considered building because it's landed and it's not moving. It's not a vessel anymore. It's considered building. So we regulate all work inside that ship. Also, any work within the airport and Port of Long Beach, when it comes to permitting, plan reviews, and inspection, it goes through the staff at the Building and Safety Department. We also have about 2,000 active oil wells in Long Beach. We produce VOCs, we produce dirt work, and also will impact fugitive dust, as I will explain later on. But Long Beach used to be an oil city. A whole bunch of oil wells have dried out. The developers are very interested in developing properties that previously oil derricks and oil rigs were sitting on. So we have a procedure on how to deal with the grading, the contamination of dirt, potential contamination of dirt, and eventually, when the site is clean, allowing construction of buildings on those sites. You all have heard about the state rule about the construction recycling program. Any construction project nowadays needs to go through a process, no matter how small. There's a deposit that's posted, all the materials based on the city recycling program they have to be recycled. All that is also overseen by the building and permitting process. In addition to that, we also oversee the Long Beach Municipal Code changes. Every 3 years, as you know, building codes and also city codes will change, and building and safety is mandated to make sure that the regulations of the city and city ordinances are updated every 3 years. The process of pulling a permit or getting a permit through the city in Long Beach starts at the permit center. In 2019, we moved to the new city hall, and you will see some of the impacts of what happened to us when we moved from the old city hall to new city hall related to fugitive dust later on in this presentation. But nowadays we are at the city hall at a brand new 11-story building downtown Long Beach, state-of-the-art facility. And when I refer to a one-stop shop, any permit that's needed to be pulled from public works, planning, fire, building, staff or public come here, they go around this permit center that we have, and finally they pay their fees and they obtain their permits. We entertain about 50,000 customers a year here at this center. 10,000 building permits are issued every year. And we provide about 45,000 to 50,000 inspections. When you add up, when you divide the 250 days, let's say working days, divided by 50,000, so 200 inspections a day. So we have inspectors and plan checkers and permit center staff to address the volume of the work. On the plan check side, quickly, we get our enforcement, we get our rules through triennial code adoption. January of 2023, we adopted the building codes of the California. So now if you practice or you pull a permit for any building, grading, electrical, plumbing, mechanical work, nowadays, these are the codes of the city and codes that are enforced in California. We are pretty big with the training and education program for staff and our public. But the specific to grading and the specific to fugitive dust, City of Long Beach has an ordinance. Some cities, they use Appendix J of the California Building Code for the grading ordinance and grading regulations. Most of you may recall when Schwarzenegger was the governor of California, he wanted to come up with the California Green Building Code. And by the end of his term, this new code came about, which is now it's called Cal Green or California Green Building Code. Some of the regulation related to resiliency, related to construction material salvage, recycling, fugitive dust, waste management, topsoil protection, landscape design, that nowadays are enforceable and a part of the cities and local jurisdictions regulations are sort of detailed and spelled out in the California Green Building Code, which it was referred to through presentation by Dr. Rahai today. On the inspection side, again, we do substantial amount of inspection, but our inspections include demolition permits, grading permits, and bond release, and grading and site dust control inspections. There's a huge trend right now on building small residential dwelling units. I was just looking at some statistics this week. We have issued 2,700 ADU permits since 2016, since the law came about. And then again, when you divide 2,700 by number of 5 years, you will see there's a lot of residential construction, grading work right to people, adjacent neighbors, and homeowners. Going back on for giving you some sample projects that we had to deal with since 2016, 2017, City of Long Beach has had several city hall, but it was determined that our previous city hall was not seismically feasible, was too expensive to seismically upgrade, and there were a lot of mechanical issues. So the building that was built in 1972 had to be demolished. So the pictures that you see happened right downtown Long Beach. Some of you who have lived or come to Long Beach remember 14-story tall City Hall that was demolished under huge scrutiny, under very large set of eyes watching this project, because it was right downtown, exposing apartment owners, commercial buildings that they are overlooking at this site. So when a demo came in, there was a conversation or discussion about potential implosion of the building, because obviously contractors want to get this thing done quick. But because of the AQMD rules that we just mentioned, the implosion of the building was not feasible. So this building was dismantled piece by piece. Time-consuming, very expensive procedure, but done very right. We had water cannons, we had water tanks, water trucks, making sure that the demolition that happened during the summer days of 2017 and 2018, and took even to early part of 19. It was done properly. They had built a new city hall. By that time, they moved all the staff and they started demoing this building. The building was completely gutted inside first, and then concrete panels they were dismantled from the building, crushed in place, under watering process, and different materials got segregated due to the recycling program that this project had to go through, all on site, all within control. I want to say under a lot of scrutiny by the South Coast Air Quality Management and other watchdogs that they watch this project. Nowadays, if you ever come to the city of Long Beach downtown, after demolition was completed, this was the last piece of the Verandil Truss that I took a picture of it. And this is a new city hall, as you can see the cursor. Right now, there's a city hall and Port of Long Beach, two buildings built side by side as a part of this civic center improvements. And this is the site that currently is waiting for future developer. But as you can see, site fencing, silt straw bales, also regular watering and soil stabilization is done to make sure that in case of rain or in case of water, we don't have water quality management issues or air quality management issues. When it comes to a local jurisdiction overseeing and making sure that the dust control and demolition permits are regulated properly, I'd like to run you through this list so you see the complexity of this matter a little bit. Let's say a demolition has to happen in a coastal zone area, or a demolition project has to happen in a historic site of the city, historic building. The planning department has a lot of say-so about that. Let's say if a demolition needs to happen within a public right-of-way, Public Works Department looks at it. Before any demolition happens, the gas lines and utility lines have to be cut because you don't want to start demoing a building or a project when the utilities are active or live. So Long Beach Energy Resources Department, which is basically gas department, has to be notified. So they come in from a standpoint of utilities and making sure the utilities are cut, as well as the other neighbors don't get hurt or don't get impacted because of your line is severed. Health Department and Human Resources involvement, also interesting. Anytime you bring a big dozers, big equipment to any sites, anytime you demo a building, you're gonna have a lot of insects, a lot of mouse and rats and ants loose all over the place. So Health Department regulates size, demolition size from standpoint of vermines, from standpoint of the gophers, rats, ants, and other animals that could be on the site. Obviously, depends on the terrain, depends on areas. The animals or the species could be different, but pretty much through all the jurisdictions that I've worked with, upon demolition permit, a health department gets notified. Needless to say, South Coast Air Quality Management District has a lot of say-so. We make sure that grading projects or demolition project contractors report their projects to South Air Quality Management, and they give us a paperwork that's an evidence that they notified air quality management. That's a part of the requirements. CalOSHA also get involved. Depends on type of equipment you bring to town, depends on the kind of work that you do. Or my colleagues just showed you a picture of an individual or a team of individuals who had to be on a very large crane to water down a post and columns from a bridge. The same thing here. On this picture, you see we had people on the elevated platforms and elevated lifts to water down the debris and construction. So operation of any special equipment, any special devices requires OSHA permitting. At one time in my life, I used to be a contractor, and I recall a project that we had in Claremont, major grading project, completely different site work. And I had to learn how to operate the dirt truck and also water truck because the crews were not showing up. So sometimes contractors are in a bind to address high winds that their projects get hit with. And then you have to have water tanks, water equipment, facilities on standby and ready to deal with it. Speaking more about the departments, Harbor Department also gets involved when the projects are in their property and territory, as you heard from my colleagues before. Long Beach Water Department gets involved in order to make sure there is water on a site or water meter is closed, shut down. Also Edison from standpoint of electricity, and make sure that there's no severance of their electrical lines and potential problems. When all these bureaus and departments and agencies are final, they provide a letter, they provide a statement to Building and Safety Department, because we are the clearinghouse for all these above agencies. So when a building permit is issued, or let's say a demolition permit, it's the job for a building department to make sure that all these above I's are dotted and all T's are crossed. Then a building permit is issued. We obviously have our own plan review and our own regulations when it comes to buildings and major grading projects. Any building taller than 5-story, if it has to be demoed, or if it's a subterranean or basement structure, which could impact adjoining buildings, we will have special plan review requirements for them, or if they're bringing special racking equipment to town. You all have heard and seen through videos that sometimes they use a racking ball to demo a building. Sometimes they dismantle a building piece by piece. Sometimes, I mentioned it early on, where it's allowed, you may have agencies may allow implosion of the building. But all in all will result to a lot of dust, result to a lot of fugitive dust that needs to be mitigated and controlled. Here is another example of a project that we were involved, my staff were involved, major grading project, city project. We were there from the standpoint of air quality management. It was managed under public works contract, but anytime a project construction gets through public works, the Building and Safety in Long Beach is a plan reviewer for those projects. So we have to make sure, again, all those agencies that I mentioned before, they have signed off on a job, and if they're in a special requirement before the grading permit for this job could have been issued. Associated with other construction project, this is a project that we currently have under construction. It's a hotel project, 4 or 5 story below grade, and then 4 or 5 story above grade. It's a Asian developer that's developing this project. The contractor last week had a bottom out celebration. In other words, they excavated the land. As you can see, his property is right by the Ocean Boulevard. If you drive to Ocean Boulevard, this is the last piece of the land that is allowed in the city of Long Beach to be constructed oceanfront. There are not too many pieces of land left in entire California that a city or an agency allow a construction this close to the ocean. But having said that, high water table, high winds, dirt. I was visiting the site last week, and the dirt is really nice dirt from standpoint of contracting and compaction, but from standpoint of creation of the fugitive dust, it's the very soft, smooth dust. We were actually very surprised, right by the ocean, which is generally sandy soil. We have a site that has got this kind of soil and has to be protected. As you can see, the extensive shoring that the contractor had to build to protect adjacent neighbors, to make sure there's no water seepage coming through, all that was mitigated, and the site is ready for about a year and a half construction that's coming away. I briefly mentioned about oil wells and proximity of the construction to oil wells. City of Long Beach still has a lot of active oil producing wells, but more and more these oil wells are drying out. And when they dry out, the developers find this very precious piece of land that they want to build in Long Beach. So this shows a typical equipment that it takes to cap an oil well and provide plugs in an oil well to make sure that the oil well, it is fully abandoned per either state standards or for the city standards. Very expensive ventures. Each well sometimes costs about $2 million just to abandon, but that's cost that the developers and oil well companies are going through. But back to the fugitive dust, these sites, a lot of materials will come out of these wells, sometimes contaminated, sometimes clean. Concrete plugs have to go in, and it takes sometimes second-hand PCH. For those of you who have lived in Long Beach, you may know this brand new shopping center now is built there, and they had 5 or 6 oil wells to abandon. This is another site that's now a True Value store, and a Chick-fil-A is built right here. That was close to the oil well. We go through AQMD, and we go through a lot of CalGEM requirements to make sure the sites are clean. Methane and other soil contaminations are also part of these sites. Showing you those sample projects, we have several different bulletins in City of Long Beach on our website that if somebody's interested to look into these matters regarding grading, regarding wind design parameters for the City of Long Beach, construction demolition management plan that needs to be in place, obtaining demolition permit, procedure for obtaining demolition permit, and funding construction vicinity oil wells. These are 5 bulletins that I thought would relate to fugitive dust and the work of the contractors or audience that sits in this presentation. Last and final element that I'd like to put up, every city, every agency is supposed to have a map of their wind zone or wind map. So when a structural engineer or an architect or a building designer needs to know about the wind speed in the cities, by the state law, the cities are supposed to establish that. This map shows the wind map of City of Long Beach. We can get up to 110 miles winds in Long Beach, and that's what we design buildings based on. The 25 miles per hour is the requirements for the site grading and stopping the grading project to make sure dirt doesn't get in air. But when it comes to building design and other elements of the wind, we push up to 110 miles per hour. And city has 2 zones. The oceanfront area, which is exposure D, higher exposure. You see this oceanfront, the cross-hatched area. And then the rest of the city, that is exposure B when it comes to wind. Long Beach Airport is right at the almost center of the city, right here. When any grading happens around these sites, we are very concerned, we are very careful when it comes to dust control, dust mitigation, in order to make sure we don't create an issue for the airport. Also, any grading job, any demolition work, including that hotel that I was just showing you, that happens in this sliver of the land in front, more concern, more potential winds, way more over 25 miles an hour. And that's where we know we need to know to stop the job, no grading, that kind of work. Well, this gets me to the last slides of City of Long Beach. Some of you may be familiar with this old look of Long Beach. This is the new look of Long Beach. This is a building that was remodeled recently. This is what you see. Sometimes we forget what we had and where we are nowadays. But Long Beach is moving very fast. There's a piece of land left in here by Pine and Ocean Boulevard. That's the largest high-rise is proposed for City of Long Beach. The developer is looking into start construction there potentially in 2024 or 25. That will finish my presentation, and if there's any question, I'll be glad to entertain.
Thank you so much, David. That was an exciting presentation, a complexity of the getting permit within the city of Long Beach. And I'm sure within any city, but city of Long Beach kind of, because being an oceanfront city and having ports and airports and everything is probably much more involved than any other regular standard city. Any questions for David? Any question? No question, and we are just 4 minutes to noon time, almost done. So if you don't have any question, I want to thank our presenters, David and Austin from the Port of Long Beach, David from the City of Long Beach, Ken from Griffith Company, all of our presenters for these great presentations, and that should conclude our workshops on fugitive dust. And I think that, Scott, we have a Mentimeter, right?
Yeah, if we can hang on to everybody for just a couple more minutes. We wanted to get your feedback. Our goal today was to bring together academic rigor and industry best practices, which hopefully brought some good information for you. But your feedback can help us to tweak, to refine, to make the next class that much better. So if you would, we'll approach it from the same processes we did before with the questions, but now it'll be much more related to the class. So for instance, did the level of content, the depth of the material in this course meet your expectations? Could have been too easy, could have been too advanced, or it was just what you were looking for, which these are excellent answers. Okay, thank you for that.
Thank you so much.
Next question, were the course topics relevant to your work? Did you find that this sort of intersected with the type of work that you do and was kind of what you were expecting from the class? I appreciate that. Just in terms of open thoughts as you were going through the last 3 hours, what would be your suggestions for how we could improve this course? That might be more examples, more in-depth lectures, some activities, in-class activities. Hamid, you don't get to write in.
I didn't put that in.
And if you want to think about it a little bit and send us an email with some comments, since this was the first class, we welcome those as well.
Okay, any other thoughts before we move on? Next question. If this was a good fit for you, would you recommend it to a coworker? Okay, appreciate that. And I think finally, when you think about this, and Hamid has a whole roadmap laid out for sustainable construction courses. What topics in particular would you like to see covered next? What would be most relevant to the work that you do, or where you've got areas that you're interested in pursuing? And know that this is across the whole domain of sustainable construction, engineering and planning practices, which might be green buildings, it might be health monitoring. What are some other good examples, Hamid?
We talk about structural health monitoring, that we are planning to introduce, which is very new, and I don't think anybody has offered this course. And it's a new way of looking at and maintaining or inspecting constructions. And, that I think that I'm hoping that, that would be the case. And I see that heavy mitigation, definitely we have a module within the, environmental impact of construction on, emissions and mitigations that we will be offering as part of that course, definitely in the works, and hopefully very near future we will have that one.
It sounds like PM 2.5 would be a good addition too.
Yes.
All right, appreciate that. Everybody, thanks so much.
Thank you so much, everybody.
Thank
Thank
you.
Thank
Let me
you.
add my thanks as well.
Thanks, everybody.
Thank you so much.
Have a
Thank
great
you.
rest of the day.
Take care.
Yeah.
Take care.
Have a great
Bye-bye.
rest of the day.
Thank you.